Sorry, I cut myself off again. It could be a thing you tried here. You can do that little integral by parts. Probably that's not a great idea. I haven't tried that out in a while, but I don't think that goes anywhere. Just do the one big parts. A couple more examples of integration by parts. Here's an example where it's probably overkill. Let's do the integral of 1 over x minus 4. Hey, if you see this, do the u substitution, u equals x minus 4. That's a real simple thing to do. But let's try it out by parts. This is one of those places, it's sort of a chance to show off why you might want to do something goofy. So we're going to try doing our u is... So, sort of unfortunate that both substitution and parts involve picking a u. When I say try u equals 4, I mean try doing the substitution u equals x minus 4. We're going to try this by parts, and we're going to let u be the 1 over x minus 4 part. So dv is just the 1 dx. du is the derivative of this. It might help to write that as a power of negative 1. The derivative is negative 1, new power of negative 2, times the derivative of the inside. Well, that's just 1 dx. What's v? v is the integral of 1 dx. That's x. I'm allowed to put plus a constant here, but I usually don't want to do that. This gives me... This equals... Oh, I didn't write the uv. uv... I'm not going to fill that in just yet, because here's the place where minus the integral of v du. du is negative 1 over x minus 4 squared times v. Well, my v right now is x. That sort of doesn't make the problem any easier. The thing I want to do instead is I'm allowed to put a constant in here. Why don't I put a constant of minus 4? If I make an extra x minus 4, well, hey, presto changeo, now I've got something that cancels with the original fraction. That's great! So here's a version of when you might want to put the plus a constant. It's the reason I'm putting it there is because it is exactly what I need to make something simplified. I don't think there's anything like this in the homework. I'm sure there are places where you could notice that you can do this trick. This is just me showing off a place where you can use this trick. What do I get? I get uv, that's 1 over x minus 4 is u, times v is x minus 4. Make sure you're using the new v. If you change your v, remember it affects what's going on in the uv part, not just the old part. What do I get? I get... Oh wait, this is not good. I get 1 minus negative makes this a plus. The integral of, when that cancels, I get 1 over x minus 4. This was not a great example. Doing the integral by parts turned our original integral into a new goofy different integral. I thought this would be a good chance to show off why you would want to add a constant, but the integral by parts was already a crazy idea here. Not a great idea. Nope. Scratch that example. Do I delete this video? Nah, this is part of it integrating, is seeing things that don't work and trying something else. What should I do instead? Try the substitution, u equals x minus 4. This is the baby kind of substitution that it's fair game to do in your head. The integral of 1 over x minus 4 is just natural log absolute value x minus 4. You can write out that substitution if you don't feel comfortable doing the baby type substitutions in your head. Let me show off one more weird example. This one's kind of a funny one. We're going to integrate e to the 4x cosine 3x. What do I want to pick as my u? I got two candidates, e to the 4x and cosine 3x. Neither one seems obviously better than the other. I guess I'll try the e to the 4x. That makes dv the other thing, cosine 3x. du is, what's the derivative of e to the 4x? It's 4 e to the 4x dx. V is the integral of cosine 3x. What's the integral of cosine 3x? It'll be sine 3x, but gotta divide by 3. I could put a plus c. I probably don't want to. So that integral is uv e to the 4x times 1/3 sine 3x minus the integral of v 1/3 sine 3x du is 4 e to the 4x dx. I'm going to smush the constants together because we're about to do integral by parts again. And I like doing that with a plus here, so I don't have to worry about combining like terms or like pushing the constant out front of the integral into the new integral formula, the new integral by parts formula. I get negative 4/3 sine 3x e to the 4x dx. I want to do parts again. What do I want my new parts to be? It's going to be tempting to let u equal negative 4/3 sine 3x. But hopefully we learned the lesson that when you do parts twice, you don't want to undo the old thing. If the u is the thing that came from being v, then I'm about to untie the knot that I just tied and just turn my integral back into itself, the original version. I don't want to do that. So I want to keep marching forward. I want to let u be the part that came from the old u. Here that'll be the e to the 4x part. The e to the 4x part is, let's stick the constant on there too. Let's make it negative 4/3 e to the 4x. dv is everything else is sine 3x dx. du is now derivative of that. It'll be e to the 4x. Multiplied by 4 gives us negative 16/3. V will be the integral of sine 3x. That'll be negative cosine 3x, but gotta divide by 3. This thing has a dx on it. What does my new integral become? I get equals 1/3 e to the 4x sine 3x plus here. Now I gotta use the integral by parts formula on this formula. I get uv is negative 4/3 e to the 4x times negative 1/3 cosine 3x minus the integral of v, negative 1/3 cosine 3x, du is negative 16/3 e to the 4x dx. I want to pull the constants out. I got negative, negative, negative. We'll make negative 16/9 integral e to the 4x cosine 3x dx. And I have those other two parts that are the same. Okay, here's the place where he attempted to say, uh-oh, we're in trouble. So I'm not going to copy those down just now. Here's the place where we're in trouble, e to the 4x cosine 3x. That was my original problem. This knot has untied itself. But wait, it hasn't. When the knot unties itself, you get this integral equals, these things canceled out to become 0 plus the original integral. You end up with an equation, the original integral equals the original integral, which is not helpful. We're ending up with the original integral equals something that's not 0, or sure doesn't seem likely that this messy thing is all 0. And now not plus itself, it's minus a different constant times the original. Here's the goofy thing you can do. The thing we wanted for, let's call it I, is the original integral. We got I equals some stuff minus 16/9 of the original integral. This is an equation that you can solve for the original integral. I'm going to do the ridiculous thing and add 16/9 of the original integral to both sides of the equation. What's 1 plus 16/9? I think it's 25/9. Let me switch to a new video before I get cut off.